as you can see on the screen, today we are working with bitwise operator, that is AND, OR, left shift and right shift. First one is right shift and second one is left shift. There are other operators also like XOR and complement, or you can say there is a tilde sign in bitwise operator. But yes, they are the operators which are not generally used in the programming, but these are the 4 operators which are used in the programming, and we are going to cover these operators here. What does it mean? What is AND? Generally we use double AND sign when we are using logical operators, double OR sign when we are using logical operator, which we have already worked with. So what does it mean? We will assign a value int n, just we will say is equals to 5, and if I say int m is equals to 3, and if I just go with like this statement, if I say print f, and if I just put %d here and I put a comma here, and when I say n, double, not double and, single and, that is single and m. If I just try to run the code, and if I just run it, and what I get, we will see for the case of AND. If I am saying AND, what I get, I have printed it and I'm just saying that this is it gives me 1. How it is going to give me the 1 value? We have to just see whether it is giving the value 1, that is 5 or 3, and the value is 1. How it is possible? See, you have to remember this, that it is giving the 1 value. First we will convert, as we have already worked with the number system, that is decimal to binary and binary to decimal in the previous video. You can watch that video and you then come back to this video, otherwise you will not be able to get the point. So 1 is the value which I am getting from it, and now I just want to see why the value is 1 here, why not the other value or something like that. So we will say n, we have to first convert it in, it is internally how it is going to work with the bitwise operators. It's not that a logical operator like true or false, it's different. So here you have to convert it into binary first. So n binary, that is 5. So we know we had already worked with the binary number system, so I know 101 will be the value. If you are considering them in a digit, so you can put like 4-digit number, 4-digit values. So you will say 0101. So we know now that 101 is a value for 5, and what we know, what is the value for 3? So we know the value for 3 is, if I consider 4 digits, so 0011. So this is a value for 3, this is a value for 5. So internally what it is doing, it is putting inside one operator, that is AND. So AND means it's a logic, it's not a logical AND, it's a whatever you have study in your gate system, that is OR gate, AND gate, maybe you have done, may not you have done, but if you have worked with the decimal to binary conversion and binary to decimal conversion, then it will be easy for you to answer this. So now what happens basically here it is ANDing. ANDing means what AND truth table or AND gate says. It says if I am putting 0 1 0 here, and if I am putting like this, I'm ANDing with the, one second, I'm ANDing, just try to understand that. I'm going to AND them. So what will be the result here? It says result will be 0 0 will be 0, 1 0 will be 0. It's a multiplication basically here. 1 0 will be again 0, and 1 1 will be 1. So this is the answer for if I am putting between, what I am putting between AND, that is bitwise AND. It's not a logical operator, it's a bitwise operator. So bitwise is based on the bits. So we are saying these are the bits, 0 and 1 are the bits. So we say 0 0, that is multiplication, 1 0, this is a basically a if you have done the computer organization in your btech, BCA, or in any other subject, you may be aware about the gates, and if not, no worries, I am here to explain each and everything. What you have to consider, multiplication table. So 0 0 0 multiplied by 0 is 0, 1 multiplied by 0 is 0. 0 multiplied by 1 is 0 and 1 multiplied by 1 is 1. So what I am getting? I am getting 0, 0, 0, 1. That is the answer for, you can say, decimal value of, that is a decimal value of 1. Is that clear? Now, if I change the value, if you say, okay, this is 1, now I want to change the value to this. I don't want 5 and 3, I just want to make any other value. So suppose I say this is 4 and this is 6 here. Okay, so now we will see what will be the value for it. If I just try to run the code, very easily you have to understand this. So what it will give me the value? It is giving me 4. So that means how it is going to give me the 4 value? So this is a question which can be asked in interviews also, and that time you are getting confused if you are not having the knowledge of binary digits and all. So that's the reason I'm always saying you that please go through the previous video first and then come to this video. Okay, so if n is 4, so 4 means we know binary, we have already worked with the binary digit. So 4 value means, first calculate the 4. So 4 is 0. If I put it like this, 1, 0, 0. Okay, and what is the value for the 6? So we say 0, 0, 1, 0, 1. No, not this. This is your 0, 4th digit, then is a 2. Yes, trick method. If you remember the trick method which we have already worked with that. So this is my 4 plus 2, that is 6. So this position is 1, this is 2, this is 4. So 4 plus 2 is 6. Okay, done. Now I want to calculate what? ANDing between them. So what I do? I just put them like this. I just put them like this. Yes. Now if I say what will be the result? So 0, 0 is 0, 1, 1 is 1, 1, 0 is 0 and 1, 0, 0 is 0. So now if you can see what is the what is this place? This place is exactly same. It is reflecting, which is the value for 4. So I am getting the result 4. If I just try to run the code, I am getting the same result, that is a 4. That's the reason this AND is giving you the 4 value. Hope you understand this concept now. I am trying to, clear this concept very, in a very beginning level, so that it will be easy for you to understand. Sometimes for an interview it is very difficult to understand what will be the value for this. In the similar manner, there is another operator that is called as OR operator. Instead of this AND, you are putting a single pipeline, not the double. If you are putting double, that means it's a logical operator. We are not considering here logical operator, we are working with the bitwise operator. Bitwise will be always single. So I put a shift with the pipeline, that is a pipeline, I am getting the pipeline, and then I just say what will be the value for it. If I just try to run the code and I just see what will be the value, and I just see what is the value. Now this time it is giving me the different value, that is 6. Okay, now if I change this to, first we will go with this 6. Again we have to convert it into binary and decimal. So first value is what? It will be 0, 1, 0, 0. We know that. Second value is what? That will be 0, 1, 1, 0. We know that. Now it's saying you have to do OR, that is bitwise OR. So you remember this thing. Bitwise OR says it is a basically sort of addition, but you have to remember when 0 plus 0, it will give you 0. When 0 plus 1 or 1 plus 0, it will give you 1. And when it's 1 plus 1 will be there, it will be 1. And carry 1, that is not affecting here, but you have to remember this one. 1 and 0, 0 will be 0, 0, 1 or 1, 0 will be 1, and 1, 1 will be 1. So this thing you have to remember always and always. Okay. Now considering this thing, what will be the result now? We will say 0 plus 0 is 0, 1 plus 1 is 1, 1 plus 0 is 1, and 0 plus 0 is 0. So if you remember what is the binary form of which decimal place, which decimal value we had already worked with, that is 2 plus 4. So it will give you the value. That's the reason it is giving you the value 6. Hope you are able to understand this. If not, we will take another example. We will take the same example which we had done, 5 and 3. This time if I just try to run the code and I see what I am exactly getting, so whether I am getting the same result which I was getting, no, I am getting 7 now. How? 5 and 3? It's how it is possible 7. So we will see though. We will change it to, it is 5. So now it will be 0 1 0 1. So we know the binary. Again I am telling, if you are not able to understand how I am putting 0 1 0 1, just go through that video which we had already worked in the last one. Just go through that binary to decimal and decimal to binary conversion and then return back to this please. Okay, so 0 1 0 1, this is the 5, and then I am saying 3. So 3 binary is not this, 3 is like this. Okay, now what we have to do, we have to or means addition, but like 0 0 is 0, 0 1 or 1 0 is 1, 1 1 is 1. So 0 0 is what? 0. We are saying 1 0 is 1. In case of AND, it was 0, 1 0 was 0, multiplication. Now here is addition, 1 0 is 1, 0 1 is again 1, and 1 1 is again 1. So now if you just go through the binary to decimal conversion and decimal to binary conversion video, you will see this is a binary of 7. This is a binary of 7. So that's the reason if I just try to run the code and I am getting the value 7 here. Yes. And if you remember the procedure, how we were calculating the 7, we were saying 0 multiplied by 2 raised to power, it was 2 raised to power what? We were calculating like that, 2 raised to power, and you have to index it 1, 2 and 3 like that. So when you 0, 1, 2, so 2, 0, 1 and 2. In this way you can calculate. So if you remember, if you don't remember, just go through that video and you will be able to understand how we are going to calculate. But still I think in this video also it is clear to you people. So this is about OR. So and OR. In the similar manner, there is a right shift operator. This is called as, this operator is called as, I just put it here, and this is bitwise and, this is bitwise OR. This is your right shift operator and this is your left shift operator. Okay, remember this. Now we want for the left shift and right shift. Suppose we change a value here. If I say, I'm saying 1, m is 5, n is 5 and m is 1, and I am putting a right shift here. I am putting a right shift here. Now just try to run the code and see what is exactly going on and what will be the value which I am getting. Now I am getting a different value here, 2. How I am getting, I just see how I am getting. I just delete this one from this. So first value is 5 and it is saying here you have to right shift it one time. One time means the bits here, I just explain it like this. So 0, 1, 0, 1, they are at a particular position and I just want to shift it one time. Shift it one time means this bit will not be there now and the position will be like this. I'll just explain you. The position will be here, it will be 0, here it will be 1 and here it will be 0, and now this is blank, here it will be 0. If you remember that. So when we are saying right shift means the last bit which is at the right position will be lost. So will be, that means next time you don't have to count it. You don't have to count it. You have to just, shifting, like we are saying shift one place to. So we have to just rotate it one place and then this bit will not be there, right? So if I am shifting it, so 0, the second position will be first position, the third position will be second position, the fourth position will be third position, and at the fourth position it will be 0. So what I am getting now, I am getting 0 0 1 0, and if I just remember the concept of binary to decimal and decimal to binary, I see, and if I consider the trick method also, so trick method is 1 2, so my answer is 2. So that's the reason I am getting, if I am shifting it one time, so I am getting a answer 2. If I shift it 2 times, if I say, oh, don't worry, we want to shift it 2 times. So now it's very easy for you. If I am shifting this again, now my value is this. if I'm shifting it one time more, so this 1 will be in the first position, isn't it? So now if I just try to run the code, so what will be 0 0 0 and 1, because I'm shifting one more time. So now my answer should be 1. Now my answer should be 1 instead of 2. See, I'm getting the answer. Exactly. Very good. I think it is understandable now. It is clear to you. Now in the similar manner, there is a left shift. Now I am shifting to the left. That means now the value will be the same, but I am shifting to the left. Now first we will see one time. One time means this 0 will be dropped. This 0 will be dropped and the value will be here what? I'm just trying to delete the whole thing here so that it will be easy for you to clear. Okay, so 0 will be dropped. That means 1 will be at the fourth position now from the left. Then 0, then 1, and then here this position is blank now. So I am putting a 0 here. So that means this was 5. Here the value was 5. Now I am getting, this is 2. This is enable 2, enable 4. So I am getting 6. So if I just try to run the code and I see what will be the value and I'll get the value. No, oh, I am considering the wrong way. See, if I just go with the trick method, how it should be 1 0 1. So this one, this will be index 1, this will be 2, this will be 4, this will be 8. So 8 is enable and 2 is enable. If you remember, if we had done in the previous video, 8 is enable and 2 is enable. So 8 plus 2 is 10. That's the reason it was giving you 10. Okay, we will just take one more example here. If I just, instead of this 5, if I take 7. So if I take 7, if I run this, instead of running, I just calculated first. 7 means here the value will be changed. 7 will be this 1. There is 4 plus 2, 6 plus 1, 7. So I am getting the 7 and I have to move it one time. So now what will be the value if I just delete this one now first? Okay. So just calculate it yourself. So 0 will be dropped, 1 will be here, 1 will be here, 1 will be here, and 0 will be here, because 0 will be dropped and it has to be left shift to the left position. So now the value is what? This is 8 plus 4, that is 12. If I use a trick method which we had done already in the previous video. So this is the position number 8, this is 4, 12, 12 plus 2, that will be 14. And if I just try to run the code and if I see whether I am getting the same value, we have to just check the value whether we are getting the same value or not. Exactly, we are getting the same value, 14. In this way, we have to remember how we are going to left shift and right shift. It's very easy if you have an idea of binary digits. Simply binary and decimal, not octal and hexadecimal we know we require here, but binary to decimal at least you should know. Okay, so if I just try to go with the 2 shifting, that means I want to shift 2 times now. So here the shifting will be 2 times. If I shift it one time here, I am getting this, and if I shift it again one time, so what I get? So what I get, 1 will be dropped now, 1 will be 2 and 0 will be there, because this one will be dropped now, this one will be dropped because we have to left shift it. That means it will be lost. So 1 1 0 0. That means you have to, now it will be 8 plus 4, that was 12. Now I should get the answer 12, exactly the 12. So this is okay. If it is giving me some wrong value, what is the value here? Okay, okay. See, here I am shifting it to the right. That means if I am shifting it to the right, that means this position has to be dropped. Okay, here I am little wrong, we will again do it. See, I am shifting, this is my first position. If I am saying 2 times we have to change the value, this is 7. One time I am changing the value, then it has dropped and it has given the value like this. Now if I am just shifting, that means if I am shifting, that means in this position value will be there, that means in the 4th position. So 1 will be there, then 0 0 and one more 0 will be, because it has to shift to that particular position. In this, are you getting? Because in binary systems, digits are like this. I'll again explain you like this. So if like this, if the value is 1 1 here, and I'm just going to shift it to the left one time. So what it will be, it will be, the value will be shifted to here next time, and it will be 0 0, isn't it? So shift means you have to go to the next level. If I again shift it one more time, then 1 will be it at this position, right? So in this way you have to, because left shift will not be like the right shift, because in the left shift digits are always to the left and left. That means it will be expanding. If the value is 2, then it can be 4, then it can be 8, then it can be 16, like that. I hope you remember it. And now if I just try to run the code again, if the value is there, now the value is, this is enable, that this is 16, this is 0, this is 1, this is 2, this is 8, this is, what is the 8, and this is 16. 16 plus 8 is what? 16 plus 8 is what? The value will be your, the given value is there. I think it is giving the same value. So if I just try to go with the 5 here, and if I just try to run the code again, and we will see whether it's working or not. Sometimes it is like that, it's saying 20. Okay, we will just go with the, whether we are getting 20 with the 2 rounds or not, we will see. So we will delete this one because I am not satisfied with my answer, so I'm just trying to go with again. So 5 means 0 1 0 1, so I have to shift it 1 times to the left. So that means first I shift it to the left 1 time. So what I get, 0 is dropped, 1 0 1 0 will be the value. Okay, and then I have to shift it 1 more time, and then what will be the value here? 1 is dropped, 0. Okay, what will the value? Then left shift again to the left shift. Okay, so shift it 1 time. So here the value will not be dropped basically. The reason behind is because it is shifting to the, it's not dropping the value, it has to be shift. Okay, so what is the value here? This is 1, this is 2, this is 4, this is 8, this is your 16. And if I just try to run the code, and I'll just see what is the value I am getting, I'm getting exactly 20 value. Now it's clear. So one thing you have to do, remember this, here bit will not lost. Sometimes happens, you have to remember this, bit will not lost, bit is there. Okay, bit is there, just it is just increasing its range. Okay, like we will do the same thing with the 7 now. 7 was the value, again I am trying to go with the thing, sometimes it is confusing. So 7 is what? 0 1 1 1. Okay, then I am shifting it to 1 times. I am saying 1 time shifted. So what I get 0 will be shifted, but 0 will be there, and then 1 1 1 and 0. Then I have to shift it 1 time again. So what will be the value? 0 will be there, 1 1 1 0 0. Okay, now if I just see what is the value. So 1 2 4 is enabled. Okay, if I say 4 is enabled plus 8 is enabled plus 16 is enabled. Okay, so 4 8, that is 12 and 16, that is 28. If I just try to run the code and see whether I am getting the correct value, which yes, now it's true. Now we got the answer, and it was a method. I was doing something wrong when bits were lost. So it is the way how you are going to go with the, sometimes it happens with us also, that whenever we are doing something and it is going wrong, but by making some mistakes you learn how to do it correctly. And that's the reason 99% students drop this topic, because it is little confusing for us also, for you also. But always remember, by failing you will succeed. If you will not make the mistakes, you will not get success. Okay, so I think that's it for today. You are now clear with and, or, right shift and left shift operator. So that's it for today. Take care And if you really find my content useful, please put a thumbs up, share with your friends, like the video, subscribe the channel. I'll meet you in the next such topic. Till then, take care. Bye bye.